Welcome back to Cypress Academy PSoC 6 101. In this video, I will show you how to set up an I2C dashboard for our BLE controlled robotic arm project. An I2C control and debug interface is handy to understand because you will more than likely have multiple sensors or ICs in a typical system that will require this type of interface. Let's start first by learning about the I2C peripheral and the Easy I2C component. Start by creating a new project. I'll call it Basic I2C. Again, I love copying and pasting as it saves so much time. So go back to the schematic view of the basic TCPWM project that we did in the prior lesson. Let's copy that entire schematic and paste it into our basic I2C project. I want to show you an additional feature of the TCPWM component. So let's open up the configuration dialog, click on the Advanced tab. Here you can see more configuration options like the kill and start input, which we'll talk about in the next lesson, as well as how you can change the polarity of the PWM output. In this case, because the LED on the kit is active low, I want to use larger duty cycles for a brighter LED, because that just makes more sense. I'm going to invert the output of the PWM. Now, hit OK. Let's add the Easy I2C component from the catalog. Double-click on it and rename it to Easy I2C without the _1. You can also see the other configuration settings, like the address and the data rate. Click OK, and now let's move on to configuring the pins. Make sure we assign the pin for the LED to P03. Then SDA, the data signal, assign that to P61, and SCL, also known as the clock signal, to P60. Now, onto the Cortex M4 main application. Let's start the PWM and the Easy I2C components with their simple API start call. The Easy I2C component implements an EEPROM I2C scheme. In this scheme, the first byte written in an I2C write command is an offset location or a register location, followed by the data to be written at that location. Read uses the same offset location as the previous write. This allows a single I2C slave to have 256 different register locations that can be used to store data. You can also use a 2-byte offset, which allows 64,000 locations, actually 6,536. This scheme is an interrupt driven and is designed to easily set up an I2C slave in your firmware. We will initialize a read-write buffer with the set buffer API call and a local variable that we will declare called myBuffer. Because this variable can be changed by the interrupt service routine, I'll use the volatile flag to let the compiler know not to optimize it out. In the main loop, we'll simply use the contents of the variable myBuffer to update the compare value of the PWM using the standard API call that we used in the previous basic TWM project. Then we'll put the CPU to sleep and tell it to wait for the next interrupt before waking up. Any I2C command from the master will generate an interrupt which will wake up the CPU. Now we can build, program, and test our device. To test this, I'll use Cypress's Bridge Control Panel tool that comes with PSoC Creator. I'll open the tool and click on the kitprog entry at the bottom of the screen. At the top, I'm going to write different compare values to send to the PSoC 6 to change the LED intensity. I'll do this by typing W for write, 8 for the address, 0 for the register offset, and the hex value of the intensity from 0 up to 100, then P for an I2C stop. For example, W8032P sets the PWM to a 50% duty cycle because hex 32 is 50 for half intensity. Alright, how awesome is that? One note about the bridge control panel is if you want to reprogram the PSoC, you must disconnect from the bridge control panel first. Otherwise, PSoC Creator will not be able to connect to the kit prog. Once you finish reprogramming, just select the kit prog again from the bridge control panel to reconnect. Now that we understand how to implement the easy I2C with PSoC 6, next we'll add it to our BLE controlled robotic arm project. You can post your comments and questions in our PSoC 6 community, or as always, you're welcome to email me at alan_hawse@cypress.com or tweet me at AskIoTExpert. Thank you.